This is part 2 of lesson 7.2 on radical, absolute value, and piecewise functions. So in part 1 we talked about radical and absolute value functions, and they have a lot of familiarity. Piecewise functions are different. They're kind of what they sound like. They are functions, and so we know that there's a one-to-one, so like if you put in one input you get one output. Oh, and by the way, that's why radicals are functions too, because when you put in an input like square root 1, you only get one output. If we had both positive 1 and negative 1, it wouldn't be a function anymore. So that's just another interesting piece of information. Now, piecewise, the word piece, it's what it means. So you know what a piece of something is. It's not the whole thing, it's just part of it. So we're going to have parts of functions. So when we have piecewise functions, we're going to have a restricted domain. So we're going to graph this line. So let's start by doing that. So it's just a line. It's got a y-intercept of 2. It's got a slope of -1/2, so down 1/2. And so that's my line. And so if I was to get a straight edge, I want you to get a straight edge and graph that. Now, right here, what we're going to do is we're going to restrict the domain. So we're only going to want the portion of f of x where -2 is less than or equal to x is less than 4. So that means that, let me write this all in one line. I didn't really mean for it to go into 2 lines. That means anything between -2 and +4, I want. Everything outside of that, I do not want. So I'm actually going to go and erase everything after 4 and everything before -2. So that's the part of the function I want. Now notice that it says less than or equal to. So we've learned with inequalities that you have a filled in dot for that. And where it says, I shouldn't have written less than or equal to, less than or equal or less than 4, I'm going to have an open dot. So you're going to put like that. And so that's my piecewise function. It's just a piece of a function. So when we graphed inequalities, the open dot means that it's not included, and a closed dot means it is included. That actually should be in there. Okay, adjust your graph as needed. So when we talk about piecewise functions, you're going to either have an open dot or a closed dot, and you have to pay attention to what the inequalities are. So a piecewise function is literally made up of pieces of multiple functions over specific intervals, or we could also say a specified domain. And so basically we're going to look at a function, but only between here and here. All right, so that's what we're going to be doing. When you see a piecewise function, it's often going to be written something like this. Okay, so what you have is you have the function name, you have what the function is going to look like, and you have the domain. And so when we're looking to graph this, we have to look at the domain and what it's going to look like. That's the important pieces here. So I'm going to look at the first domain, and it's everything less than 1. So I'm talking about everything to the left of 1. And so the next thing we're going to do is we're going to graph that line. So we're going to start at 2 for my intercept. I'm going to have a slope of 1. And especially when you're first starting to learn how to do this, it's probably really great. Use a pencil, and then you can draw the whole function, x plus 2, and then look back at your domain. I only want the part that's less than 1, so I'm going to go back and erase everything that's bigger than 1. And so then I'm going to notice that it has a less than, not a less than or equal to, so I'm going to put an open dot right there. On the other end, it doesn't say anything about what it has to be greater than, so I'm going to put an arrow because that just means it keeps on going. This would look better with a straight edge, so use a straight edge. Okay, then the next one is going to be between 1 and 4. So I'm only going to have a function between 1 and 4. So I'm only going to have something in there. That means that everything outside of 4, so everything out here, is going to be undefined. There's not going to be any graph beyond 4. So I'm going to get this line, -2x plus 1, and I'm going to start to graph it. So I'm going to have 1. My slope is -2. And if I was graphing the whole line, it would look like this. But I'm not going to graph the whole line because I'm only interested in part of it. I'm only interested in the part starting at positive 1. So starting right here, that's where I'm interested. So what I'm going to do is I'm going to put this as a solid dot, filled in dot, because of the equal sign right there. And then I'm going to continue my graph, but I'm going to stop it at 4 because that's where it cuts off. Now, because the 4 is less than and not less than or equal to, I'm going to put an open dot right there. That's my piecewise function. It's a function because if you go to, like, say, 3, if you go over to 3, the value at that point, oh, whoops, 1, 2, oh, shoot, I did that wrong. We're actually going to extend that. I counted wrong. 1, 2, 3, 4. There we go. You're going to graph this, and we're interested till we get to there. Okay, so what I was saying is if you go to 3 and you follow it down, the value of h of 3 would be negative 5. If I said, what's h of negative 2, then I would go to negative 2, and the value is 0. If I said h of 1, if you go to 1, you don't have two answers. It can't be both of them. Notice how you've got the 1 open dot. That means that's not a solution. And so your solution at h of 1, that would be equal to negative 1. And so that's how you evaluate a piecewise function. So the function itself will look like pieces, and the evaluation is going to depend on what your input is. Okay, number 4. This one has 3 different pieces. So I'm going to have this line, this line, this line, and they have different domains. So if you look at what the domains are, I've got less than negative 1. So everything this side I'll do in purple. And then we've got between negative 1 and positive 3. So between negative 1 and positive 3. And then everything bigger than 3. So everything out here. And so I'm going to do these one piece at a time, obviously. So I'm going to start on the left. So I'll do purple with that. I'm going to go and graph this line. So I'm going to start at negative 1. It's got a slope of negative 1/2. So you can start like that and then get your straight edge. Keep in mind where we're going to be stopping this. And so I'm going to be like going like this, but I'm going to stop it right there at negative 1. So everything past that to the right of it, I'm going to erase that. So you definitely want to use a pencil here because you're going to want to erase part of your lines. Now notice that it's less than, not less than or equal to, so we're going to have an open dot. Okay, next one, 2x minus 4. So I'm going to go to negative 4, and I'm going to have a slope of 2. So I'm going to draw my line. Now this one, it's going to pick up at negative 1, so I actually need to go backwards a little bit. So it's going to be like that. But I only want the piece between negative 1, so I don't want anything past it. And it's going to stop at positive 3, so everything beyond 3, I'm going to erase that too. Now look at your less than or equal to or greater than or whatever. So this is less than or equal to, less than or equal to. So that means I'm going to have filled in dots on both ends. Now one thing, remember, a function has to pass a vertical line test. And if I draw a vertical line, it only touches that piecewise function in one place, right there. It does not touch right there because that's an open dot. It also means that if you were to do f of negative 1, it's going to be the red value because the purple value is an open dot, so it's not defined at that point for that function. Okay, the last one is going to be 2/3 x. So that's 2/3 x plus 0. So I'm going to start at 0. I'm going to go up 2 and over 3, up 2 and over 3. And so my line is going to look like this. Now I only want it for greater than 3. So I'm going to come back and erase this part of it. It's going to go on forever now because it says everything greater than 3. So I am going to have an arrow there. Now as far as open dot or closed dot, my gold dot will be open, but my red dot is still closed. Okay, so if I was going to do f of 3, it's only going to be this one point. It's going to be part of the red, not part of the yellow, but it doesn't really matter because those two intersect at that point anyway. So if I said f of 3, that would equal 2. So the point 3, 2 is part of that function. Okay, so that's how you would do something like that. Okay, now we're going to do the opposite now. I'm going to give you the graph and we're going to write the piecewise function. So remember, you have two parts. You have the line part of it and then you have the domain part of it. So if we look here, this first domain is going to be between -4 and -2. So -4 and -2. So x is going to be between. It's got a closed dot right there, so it's going to be less than or equal to, and it's got an open dot right there, so it's going to be less than. So -4 is less than x is less than or equal to -2. So I've got my domain. Now I have to figure out what the line is. So I can see it's got a slope of -1, and you can figure out it's got a y-intercept at -2. So my equation is going to be y equals mx plus b. M is -1, and then b is going to be -2. So that's my equation for my first part of my piecewise function. Okay, the second part is going to be between -2 and +1. So -2 and +1, x is between them. So now look at your open dots versus closed dots. Here I have an open dot, so it's just going to be less than. Here I have a closed dot, so it's going to be less than or equal to. Your arrows are always going to be pointing left when you're writing a piecewise function because your numbers are going to go from least to greatest. So just like when you're writing an interval. Okay, now figuring out that line is horizontal and it goes through the y-axis at 2, so your equation is going to be y equals 2. Okay, now for the third part of it, my domain is going to be between 1 and 5. So I'm going to have open dots at both ends, so I'm going to have less than on both of those. And then I just need to figure out what the line is. So my slope is up 1 over 2, so 1/2. And if I was to continue that, down 1 backwards 2, oh no, that's a little bit of a problem, isn't it? Because we can't tell exactly where it goes through right there. So we're going to have to pull out the toolbox and think about what else do we know about this. If I know that the slope of a line is 1/2, and I know that the line itself, I know it goes through the point 1, 1. So the piecewise function doesn't go through 1, 1 at that point, but it is part of my green line that I would be drawing. So what I can do is I can use point slope formula that we learned last year to find the equation of my line. So if you remember, point slope formula is y minus y sub 1 equals m times x minus x sub 1. And so I'm going to simplify that. So y minus 1 equals 1/2 x, and then 1/2 times -1. Remember, we had a review quiz about this at the beginning of the year. I'm going to add 1, and I'm going to add 2/2 because that's 1. So y is equal to 1/2 x. -1/2 plus 2/2 is 1/2. And so that's my line. So I'm going to come back up here, and I'm going to say 1/2 x plus 1/2, and that's my line. So this is my piecewise function defined. Okay, go ahead and pause the video, and you're going to write this piecewise function. So just to point out, there are 3 pieces of it. Also notice that this piece is not a line. So look and see what you can figure out about what that is, and see if you can find what you would do for that. Okay, the first one, it's going to be between -4 and -2. So you look -4 and -2, so that's my domain. And then if you look at, see what kind this is, it looks like a parabola because it's not absolute value, because it's not going at a constant rate of change. But what it's doing is it's going over 1, up 1, over 2, up 1, 2, 3, 4. I recognize that. That's a parabola. It's the parent function. It's just that it's been shifted left 2, and that's why I wrote x plus 2. So that's going to be my function, and it's going to be good for between -4 to -2. Okay, the second part is going to be, the domain is going to be between -2 and +1, and they're both closed dots, and so I am going to do the equal sign on both of them. I don't know if I mentioned that right there. Okay, but I'm going to have the equal sign there. And then I look at my line and it's a slope of 2, so up 2 over 1, and it's got a y-intercept at positive 1, and so that's how I came up with that equation. For my third equation, the third equation, it's a horizontal line. It goes to the y-axis at 1, so that's how I get that. But it's only going to be good for a domain between 1 and 5. It's inclusive on the right, so that's why I have an equal sign right there, and it's going to be open on the left. Now, one last thing to say before we have you go and start your homework. Sometimes when you're writing piecewise functions and you're writing the domain, there are some functions that you see that you are wondering, like, and you've got the two domains, and you say, well, this could be the equal and this could be that one, or it could go where this is just the less than and this is less than or equal to. That is possible. So there might be a problem. In fact, I'm pretty sure there is in your homework where those are two different possibilities, and so either one of those could be right. So you want to check the answer key, and I will point out when that happens in case you're wondering, but see if you can find it first. Okay, you should now be ready to do your assignment for this lesson.